Hello, friends. On behalf of Eastern Academy, I welcome you all to the number systems part 2. My name is Balaji Sheshadri, and I am available on WhatsApp and email. So let us get into the number system. And in the number systems, we discuss about our very well-known decimal, which we discussed on the part 1. And we started with binary on the part 1, which we are going to continue on the part 2. And we will be discussing about hexadecimal and the symbol. As I mentioned previously, it is all about ASCII, but still we need to understand it in the some section, and we thought we will be putting that part of number systems. So these four topics: decimal, binary, hexadecimal, and symbol, are generally required to understand about digital electronics. So with this, we get into our digital electronics sessions, which is required about number system. So number system is typically a part of digital electronics, and let us get into the number system, and let's welcome on to the board. As I mentioned to you on the part 1, I hope you could have practiced the binary up to 8-bit from 2 power 0 to 2 power 7, that is 1 to 128. That practice is fairly necessary for us to understand the future binary operations. Okay, so let us get into the deeper into the binary. As I mentioned previously, binary is a essence for our digital electronics. Since we are going to work with electronics, which is mostly of digital in nature in future, and so let us get to understand the language or number system used by the digital electronics. So with that, I welcome you to the board, and we'll start discussing about more on this topic. Let us continue what we have discussed in the part 1. The part 1, we have stopped here. That is 1, 2, 4, 8, 16, 32, 64, 128. That is 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. Normally, we have a thing in decimal. In decimal, if I ask you the what is the biggest 4-digit number? If I ask you which is the biggest 4-digit number, we say 9, 9, 9, 9. So there cannot be any number bigger than this in the 4-digit. So all numbers will be less than. If you say any 4-digit number, it will be smaller than this. The same way, if I ask you which is the smallest 4-digit number, you will say 0, 0, 0, 0. Any number will be greater than this, any 4-digit number. The same way here in binary, if I ask you smallest 4-bit number is 0, 0, 0, 0. 4-bit. And any number will be bigger than this. The same way, if I ask you which is the biggest 4-bit number, then it is written 1, 1, 1, 1. That means that any number will be smaller, any 4-bit number will be smaller than this. This we need to understand. So if I say 8-bit, the smallest number is 0, 0, 0, 8 zeros. The value is 0. The biggest number is 1, 1, 1, 1, 1, 1, 1, 1. In our case, the biggest 4-bit number is 4-digit number is 9999. This is nothing but 1 less than 10,000. Am I right? So the same way here, the biggest number value is nothing but 1 less than 9-bit number. What is a 9-bit number? 1 followed by 0. It's the smallest 9-bit number. If you subtract 1, I'll get this. What is this value? We written 8-bit is this much. 9th bit is 256. So let me write it clear. So 1, 2, 4, 8, 16, 32, 64, 128. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. The 2 power 8 is 256. So if you have this 1 bit extra, now we discussed about only 8-bit. Now why I introduced 9th bit is when I have a 4-digit biggest number, which is 1 less than the smallest number of 5-digit. Same way here, the biggest number 111 is 1 less than the 9-bit number. What is a 9-bit number? 9-bit smallest digit is 0, not smallest number, 9-bit 10. Let's not take a smallest number, because smallest 9-bit number is this. There is a big problem here. I explained in the last session. We need to thoroughly understand. The smallest 3-digit number is 100. What is the smallest 3-digit number? 100. But smallest 3-bit number is 000. There's a big difference. I explained to you that why we do not leave the prefix in electronics, because if you leave it, that become don't care. So there is a big difference. Smallest 3-digit number is 100. Smallest 3-bit number is 000. We always write that 000. So if I have a 1000, if I subtract 1, I get 1, 1, 1, 1, 1, 1, 1, 1, 0. So I get here this number. So what is the value of this? If you put here 1, 0, 0, 0, 0, so these are all zeros. They don't have any value. So 1 into 256. So this number value is 256. Minus 1 is equal to 255. So this number is 0. The smallest 8-bit number is 0, 0, 0, 0. Is equal to 0. The biggest number is 255. I can write this way also. Here. See here. I write this way also. Have 8 lines. 8 rows. 4, 5, 6, 7, 8. Then this is, let us say, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7. And you make it 1, 2. Let us use different pen. It's easy to understand. 1, 2, 4, 8, 16, 32, 64, 128. So if I write now a number here, 0, 0, 0, 0, 0, 0, 0, 0. Then the result is all zeros, you get 0. So you can write this as a 0. If you write here 0, 0, 1, 0, 0, 0, 0, 0, then 1 into 32 is 32. If I write here 0, 1, 0, 1, 0, 0, 1, 0, 1 into 64, 64, plus 16, 80, 80 plus 2, 82. If I write everything as a 1, 1, 1, you need to calculate all these things. 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. That equal to, you write 255. Which I have written very easily. After 128 is how much? 256. Minus 1 is 255. When all of them are 1, you can easily write it down. That is what I showed you in the last session. And before this, I just explained to you that. And there will be a small confusion. That's why I've explained. So please understand, make this table and clear it. And you can have any big number. For example, this we have a big digit. Here we can have any big number. We can have a 1, 2, 4, 8, 16, 32, 64, 128. Let me write this way. So 8, 16, 32, 64, 128. This is for 8-bit. If you have more than 8 bits, then 256, 512, 1024, 2048, 4096, 8192, 364, 384. Sorry. You can go on like this. Okay, if you have one more number, 32, 768. This is bit number. See, this is, you see, 2 power 0, 2 power 1, 2 square, 2 cube, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 2 power 15, 2 power 14. All of them are 2 power, which I have not written because it's cumbersome to write. So that's what. So we can go from 2 power 0. This goes beyond. It doesn't matter. You don't have to remember all these things. This is all tough. Don't try to remember beyond this. If you want up to remember up to this, up to 2 power 9, it's enough. Then what people did was some simplification. What is a simplification? Then I write 2 power 0 up to 2 power 9. That is 1 to 512. 2 power 10, 1024. We also start written 1K. Kilo. The kilo in our SI unit and the kilo we are using it here are totally different. And this kilo is 1024 in memory. Somebody write is a KI kilo, but we write K. Let us not confuse. So if I write 1K, it means 1 into 1024. If I write 5K, it means 5 into 1024. Same way, 2 power 20, we write 1024 into 1024. That is 2 power 10 into 2 power 10 is equal to 2 power 20. We can write as a 1 mega. Same way, 2 power 30 is 2 power 10 into 2 power 10 into 2 power 10 is equal to 2 power 30. We can write as a 1 giga. Okay, so we can write 1 kilo 1 mega, and same way 2 power 40 we can write as a 2 power 10 into 2 power 10 into 2 power 10 into 2 power 10 is a 1 tera. We can write same thing, 2 power 50 as a 2 power 10 into 2 power 10 into 2 power 10 into 2 power 10 into 2 power 10, 1 peta. Forget about that. So normally, let us write out all these things. This is we don't need now. So normally 2 power 10 we write as a, you remember from 2 power 0 to 2 power 9, that is 1 to 512. Then 2 power 10 is 1 kilo. 2 power 20 is 1 mega. 2 power 30 is 1 giga. 2 power 40 is 1 tera. 2 power 50 is 1 peta. Okay, understand this. It's all very big number. That is, we can roughly add 3 zeros for everything. 1 kilo means this much. Not exactly this. This is actually a approximate. So actual number is 1024. 1 mega means you add 6 zeros. But not exactly. It is 1024 into 1024. 1 giga is 1 followed by how many zeros? You add 9 zeros. 1 tera is 1 followed by 12 zeros. 1 peta is 1 followed by this. Most of you know that. But what I am going to explain now is slightly different. That's a trick. What I'm going to explain is not only this. If I ask you 2 power 24 is equal to how much? We can make this as a 2 power 20 into 2 power 4. We can write that as a 2 power 4 into 2 power 20. 2 power 4 is 16. 2 power 20 is mega. That's all, 16 meg. If I ask you to write, if I ask you to find 2 power 32 is how much? Okay. You can write this as a 2 power 30 into 2 power 2, because 2 is common. 3 plus 30 plus 2 is 32, equal to 2 power 2 into 2 power 30. Both are same. In multiplication, 4 into 3 or 3 into 4, both are same. So I'm doing the same thing now. Now this is equal to this. Equal to 2 power 2 is 4. 2 power 30 is giga. So 4G. Now if I say 2 power 16, 2 power 18 is how much? 2 power 10 multiplied by 2 power 8 is equal to 2 power 8 multiplied by 2 power 10 is equal to 256K. Any number, you see, let's say 2 power 47. So easy. 2 power 40 multiplied by 2 power 7 is equal to 2 power 7 multiplied by 2 power 40 equal to 2 power 7 is 128 and 2 power 40 is tera, 128 tera. Okay. So please understand, if I give a number 2 power 36, okay, you can do that 2 power 30 into 2 power 6 and 2 power 6 into 2 power 30 is equal to 2 power 6 is 64 and 2 power 30 is giga, 64 gig. But now I'm going to give you a very shortcut. This is fine, but I'm going to explain to you that why I took so much of time to explain this, because I am going to explain a shortcut for you. What is a shortcut? 2 power 32. Okay, temporarily forget about 2. 2 power 2 is 4. 2 power 30 is gig. Finish. You can directly write. If I ask you 2 power 24, so simple. 2 power 4 is 16. 2 power 20 is meg. 16 meg. It take fadafat 1 second. You write any number. 2 power 17. 2 power 7 is 128. 2 power 10 is k. 128k. Any number. If I ask you 2 power 46. 2 power 6 is 64. 2 power 40 is tera. 64 tera. You should be able to write that fast. If I ask you what is 2 power 30, so simple. 2 power 0 is 1. 2 power 30 is giga, 1 gig. This comes by practice, but you will be very surprised. You will be very surprised how this is going to be handy when we are going to discuss about our microprocessor, microcontrollers, or everything. You will know that this is the same way. The other thing also true. If we say you that, if we say 128k is equal to 2 power how much? See that? So simple. K means 1. 2 power 7 is 128, 17. So 2 power 17 is equal to 128. Done. See the technique. This technique you start writing, you understand very good. If I say 256 gig is equal to 2 power how much? Gig means 33. 256 is 8. 2 power 8 is 256, 38. So 2 power 38 is 256 gig. You don't need any great mathematics, no calculator, nothing. But you will surprise this, how this is going to be helpful to you. You will not know that. Any number, you say that. If I say that 16 tera is equal to 2 power how much? Don't worry. It is 2 power, tera means 4. 2 power 4 is 16, 44. Understand? So this is the most important thing. That is, I can do either way. If I ask me 2 power 24 is how much? I will say 16 meg. I write directly. If you ask me that what is 128G, I will write 2 power 37. See that? Any number can be written so easily. That's the way. That is the advantage of knowing this. What you have to know this? You just have to remember this. 2 power 0 to 2 power 9. That is 2 power 1. I write this way. We should never write like this. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, 2 power 9. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. That's all. You remember this. It's enough. Now, after this, you should remember 2 power 10 is K. 2 power 20 is meg. 2 power 30 is gig. 2 power 40 is tera. And if you want 2 power 50 also remember, 2 power 50 is peta, P. That's it. You remember it. Any number, any of these things, what is coming here. If I say that, hey, my microprocessor is 32 address lines. How much memory it can address? 2 power 32, 4 gig. That's all. You will understand the actual usage when we are discussing about microprocessor and microcontrollers. These are very, very handy. I said that, hey, my memory is 16 meg. How many address lines it requires? Oh, 16 meg, then it requires 24. That means that 0 to 23. You know that we start from 0 here. We do not start from 1. In our decimal number system, we start from 1 to, but here we start from 0. So if I say 24, it is not 1 to 24, it is 0 to 23. That has to be understood. So this, when I discuss about in digital electronics, for example, in tomorrow digital electronics class, we will discuss, we put a line, we put a slash, we call this as a bus. A line, we put a slash, and we say 16. And we call this as a. Normal people don't understand. We call bus, we put a line, we put a slash, and we put 16. I call A. You know what is the meaning of this? This is equal to, if I just write it smaller, so bus slash 16 A. You know what is the meaning of this? I have 16 wires. 4. Each wire is different name. A0, A1, A2, A3, A4, A5, A6, A7, A8, A9, A10, A11, A12, A13, A14, A15. I told you we always start from 0 and we end at 50. So instead of writing like this, so much big, in digital electronics, we write on small line, one line, a slash and 16 and write A. Then if I write like this, it means that I have 16 wires clubbed together. Understand? So this is a second important point which we need to know that. Okay, we will discuss this on the digital electronics, then you will know that. This one is, I'm not discussing binary, but I have explained to you that why that 0 to 15 and all coming. So those things are directly related with the digital electronics, not Chuma. But also the another biggest problem is that I understand. See, if you have a 16-bit number, 1011001100111101. God, man, it's so big. I cannot remember because I normally write like this 7,563. I write always a small number and remembering. How do I remember this 1011 everything? So what the mathematician did was simple. They wanted a binary. Here's the binary. See that? It's a machine or electronics. Electronics uses only binary, man. But he's a human. He's a human. We use decimal. But human cannot understand the binary and the machine cannot understand the decimal. So what they have done, they have created a number system. It looks like a decimal for the human and looks like a binary for the, see that the same system is looked like a binary for electronics and decimal for human being. What they did was simple. They made this 16-bit into groups. A group. Now 1, 1, 1. So 1, 2, 4, 8. That's all you have to remember. Then 1, 2, 4, 8. You have to remember only this. 1, 2, 4, 8. You have to remember this. 1, 2, 4, 8. Not more than that. Now add them. 8 plus 4, 12 plus 1, 13. 113. 113. 1011. 8 plus 4, 12 plus 1. 8 plus 2, 10 plus 1, 11. So if I write them like this, how it will become? 11, 3, 3, 1, 3. Confusing. Because I have only 4 groups. But here, how many digits I have? 7, 6. So they thought how to avoid it. So they have compromised a little bit. What they did was, in this group, I start from 0, 0, 0, 1, 0, 0, 1, up to 1, 0, 0, 1. This is 0, this is 9, that is fine. But when I have a 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, let us write on next line. I'll create the 2 groups. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, 0, 0. Okay. You have up to this 8, 0 to up to this will take. So 0 to 1, 2, 3, 4, 5, 6, 7. Okay. Now, when I write here 1000, I get 8 because 1, 2, 4, 8. 1001, I get 9. That's why I told you that very good at part 1. Then you can understand these things very fast. Now, when I write 1010, I write 10. But they said, no, I don't want 2 digits. I want to be 1 digit. So what they've written A. This A is not your alphabet A. This is a different symbol. 1011 is B. 100 is 12 C. 1101 is 13 D. 1110 is 14 is E. And finally, all 1 is a 15. You get F. So they introduce extra term 10. Now, how do I written here? 13 is how much? D. D. Then 3 is 3. 3. 11 is how much? B. I don't write like this. I write B, 3, 3, D. Now let us take this. Okay. Let us remember only this. This we know. We don't have to remember this. But we have to know. 10 means A, 11 means B, 12 means C, 13 means D, 14 means E, 15 F. This you have to remember. Now let us write a number. I write a very big number. See that? I write a very big number. See that? 111, 0, 1010, 0010, 0001, 0010, 1011, 1111, 0011. Now I split into 4 groups, every 4. Understand? Now what we got? Let us see that. This is 00013. 111 is 15. 1010 is 1, 2, 4, 8. 8 plus 2, 11. This is 2. This is 1. This is 2. This is 10. This is 14. How do I write? 3 means 3 as such. 15 means F. 11 means B. 2 means 2. 1 means 1. 2 means 2. 10 means A. 14 means E. So I write this such a big number. How many bits? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 4, 32 bits. Instead of writing 32 bits, I write like this way. E, A, 2, 1, 2, B, F, 3. Okay. So if I give a binary, you should be able to convert like this. Same way, but this is easy to remember, not a very big number. Now let us write like this. I write a number like this. I write now F2, 6, D. Simple, right? D means 13. 6 means 6. 2 means 2. F means 15. 13 means 1101. 6 means 0110. 2 means 0010. 15 is 111. Without practicing part 1, don't come to part 2. Okay, I want practice means night 12 o'clock. If I wake you up, if I tell you what is 13, you should write 1101. What is 15? You write 111. If you would like to excel in embedded system programming, if you have to get a jackpot in the jobs, these are all must. I'm not asking you to do very big trigonometry or calculus or anything. I am just asking only few numbers less than 16. That's a small thing. So any number, if I write that FB, B is 11, F is 15. 15 is 1111 and B is 1011. So write like this. So we have so many options. We have first seen that how to convert the binary to decimal by putting 1, 2, 4, 8, 16, 32. But handling that is very difficult, adding them. So how we are converting them is in a very simple way. If you write a number 1110, 1100, that is 14, This is 12. 14 is E, 12 is C. This is easy. Done. This, even I myself is slow. You should be faster than me. That level, you need to practice. If you do that, you win the game. This conversion is only a conversion. Is called hexa. Please understand, your digital electronics or computers never understand the hexadecimal. They think it's binary. But still, since binary is difficult for human, we convert that into decimal. We convert like this, hexadecimal. So human accept decimal. So if I write 1, 2, 3, 4, it is not thing. So how do we represent? So we write like this. If I write 1001 within bracket 10, it is decimal. 1001 within bracket 2, then it's binary. If I write 1001 within bracket 16, then it's called hexadecimal. Okay, so with that, let us close the part 2, and we will see in part 2 much more than this. Okay, so let's do certain binary operations and other things in part 2. Let's actually do some binary additions and everything. So basically, the whole number system has to be understood thoroughly. Then only it's easy to move on to the. This is a very parallel one. This is looks to be very easy, but the only thing is we do addition. But only thing is now we have to do with binary. I know, man, I can speak. I'm doing very good, but I can speak on my mother tongue. If I have traveled to other country, I find difficult. Same way here. You will find small difficult, but you can easily get that difficult level. So please practice. There's nothing more than that. Practice how to convert a binary to hexadecimal, how to convert from hexadecimal to binary. Same way, 2 power any number, 32 or 45, 2 power 21, 2 power 38, 2 power 21, 16, 2 power 15, everything should be able to convert by. If you ask me, what is 2 power 28? I'll say 256K. 2 power 42, 4 tera. That's enough. Your answer has to be within 2 seconds. The day you take more than 2 seconds, it means that you're not practiced properly. I will tell you this, how important this will be when you are into the microprocessor. You will not be wasting time. That's a trick. So we think very small thing, we lose it out, but finally we always feel that somewhere we lose it out. So please don't think everything is simple. It could be simple, but you need to practice. Today's world require practice. If you do these sums, 100 sums, and people think that you work for 1 month, but you could have done it in 1 day. That's a way the industry, you're getting into the industry. How fast you do that. The person who is interviewing you should get astonished by the way you work it, how speed it is, how fast you are working. So that the one which we're going to do in the class. So in our classes, we will be able to do this. I will tell you much more than this, how to practice. So when you have a time, please walk through this part 2 and part 3 also. With that, let me close the part 2 of the number system. Then we move on to part 3. Thank you. Bye-bye.